Hello, everybody. I'm your host Shruti, and welcome to another episode of Sipping Tea with Science. Last week, we looked at the bright and colorful side of our world. This week, we are looking at the other end of the spectrum, the dark and starry side of our universe. We will be talking about cosmic holes. The holes in space, billions of light years away, that are a discontinuation of the fabric of space-time itself. Now, this topic is a very controversial topic. Many great scientists, including Albert Einstein and Stephen Hawking, wrote theories about black holes. But physicists struggle as today's technology isn't advanced enough to allow us to get more proof that could make us sure of this theory. In fact, an Indian scientist named Abbas Mitra came up with a theory proving black holes don't exist. But unfortunately, his work hasn't been properly critiqued by anyone yet, and his theory never really got the international science community's attention. Well, real or not real, let's take a look at Einstein's view on cosmic holes. First off, let's talk about the most commonly known cosmic hole, a black hole. A black hole is essentially a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying, for example. Black holes can be big or small. Scientists think the smallest black holes are as small as just one atom. Now that's small. These black holes are very tiny but have the mass of a large mountain as its extreme gravity consumes everything around it. Another kind of black hole is called stellar. Its mass can be up to 20 times more than the mass of the Sun. Scientists predict that there are many stellar mass black holes in the Milky Way galaxy. Lastly, the largest black holes are called supermassive. These black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains a supermassive black hole at its center. The massive black hole at the center of the Milky Way galaxy is called Sagittarius A. It has a mass equal to about 4 million suns and would fit inside a very large ball that could hold a few million Earths put together. Another interesting thing to think about is if a black hole consumes everything around it, could it potentially end up consuming the Earth? Well, black holes don't go around in space eating stars, moons, and planets. Earth will not fall into a black hole because no black hole is close enough to the solar system for Earth to do that. Even if a black hole, the same mass as the Sun, were to take the place of the Sun, Earth would still not fall in. The black hole would have the same gravity as the Sun, meaning Earth and the other planets would orbit the hole as they orbit the Sun now. But for those skeptics who are still preparing for the apocalypse, no need to worry, as scientists have proved that the Sun will never turn into a black hole. Surprisingly, the Sun is not a big enough star to make a black hole. Scientists think the smallest black holes are formed when the universe began. Stellar black holes, on the other hand, are made when the center of a very big star falls upon itself or collapses. When this happens, it causes a supernova. A supernova is essentially just an exploding star that blasts part of the star into space. Scientists think supermassive black holes are made at the same time as the galaxy they are in, as they are found at the center of it. But they're not sure exactly how they're formed yet. Well, after learning about all this, one might think, if black holes are black, then how do scientists know where they are? Good question. A black hole cannot be seen because strong gravity pulls all of the light into the middle of the hole. But scientists can see how the gravity affects the stars and gas around it. Scientists can study stars to find out if they are flying around or orbiting a black hole. When a black hole and a star are close together, high-energy light is made. This kind of light cannot be seen with the human eyes, and so scientists use satellites and telescopes in space to see the high-energy light. Another interesting cosmic hole to look at are wormholes. They are a theoretical portal that take you from one part of the universe to another part. They are like a tunnel that starts in one place but takes you through extreme distances in short periods of time. They are like two black holes in different ends of space but somehow connected through a tunnel. Albert Einstein's general relativity laws allow for the existence of wormholes. Wormholes are a solution of his equations for general relativity, telling us how gravity works. They are hypothetical and they connect different parts of space and time. The theory of wormholes actually comes from black holes. When Einstein came up with the theory of wormholes, he never intended it to be a tool for space travel. But over the years, physicists have pondered the idea as it takes us to other galaxies in short periods of time. Whereas now, even if we traveled at the speed of light, it will take us over 600,000 years. A typical wormhole that you write down in your equations and study is unstable, and so Einstein's wormholes were determined unstable, meaning that they tend to close up quickly. Wormholes are said to open up briefly, then pinch off from the middle, closing from the middle out. Anything that tries to pass through the wormhole when it squeezes apart will get crushed. So if physicists were to use wormholes to travel through space, they would need a way of holding the wormhole open. So they began looking for a wormhole that might be different from Einstein's, one that we could travel through. Physicists soon found out that traversable wormholes needed something to keep them from collapsing, something new called negative matter or exotic matter. They believe that negative matter is the key to stabilize the wormhole. They say it would have anti-gravitational properties. The exciting and dangerous possibilities of wormholes are endless. Though it could get us to faraway places quickly, we don't really know where it will take us. It could be an exotic place with exciting phenomena, or even the core of a star. Physicists don't know of a natural way that a wormhole might arise in our universe, but can they be made artificially? One possibility physicists speculated about that might allow you to construct wormholes would be to blow them up from what's considered to be the fabric of space-time, which might contain tiny wormholes going in and out of existence. Scientists proposed that perhaps traversable wormholes could be sculpted out of quantum foam, a subatomic bubble-like structure that might exist everywhere in the universe on light scales a billion trillion times smaller than the nucleus of an atom. Although we don't have the technology to make this possible, theoretically, this is how we would do it. If wormholes can be artificially made to transport people to different points in space, is it possible to be transported into different points in space as well as different points in time? There is a thought to think about until next week's episode that will answer just that question. This is your host Shruti. Thank you very much for listening. Stay safe and stay curious.